Alright, so we are going to be graphing secant and cosecant. This is section 4.6 in our textbook. So when I talk about graphing secant and cosecant, it's essential to know the reciprocal function. So knowing that secant is the reciprocal of cosine, that cosecant is the reciprocal of sine. So in this first example, you can see that I have cosecant. I know that the cosecant is the reciprocal of my sine function. So when I talk about the sine function here, I'm going to be talking about the sine for these four values. Amplitude comes from my A value. My A is this. My B value is that value. My C is pi over 2. And my D is 0. So for this stuff here, I should be able to tell that my amplitude of the reciprocal function, the amplitude of my sine function, is the absolute value of 2, which is 2. My period is 2 pi over b, so that's 2 pi over 1, which is 2 pi. My horizontal phase shift comes from here. I'm going to go left pi over 2, and I'll show you why in 1 second. And I have no vertical phase shift. So because of these two values here, because b does not equal 1, or because c does not equal 0, in our case it's this latter, it's the c value, I have to adjust my key points. So I make x plus pi over 2 equal to 0, and I get x equal negative pi over 2. Because this is negative here, because that is negative, this and this should be the exact same thing. Negative pi over 2 meaning left pi over 2. Negative pi over 2 becomes my first value. X plus pi over 2 equals pi over 2. I get x equals 0. X plus pi over 2 to equal pi, I get x to equal pi over 2. X plus pi over 2 to equal 3 pi over 2, I get x to equal pi.
Good afternoon,
X plus pi over 2 equals 2 pi.
Crazy time, but as we have been customary and traditional, we are going to honor our students that go down to Columbus for the state tournament. And at this time, we want to commend Mr. Luke Nord, a 3-year first team all-conference, 4-year varsity letterman,
I will continue this in the next video.
Invitational medal.